So, a little bit more background on chapter 1 before we start the exercises. Payment streams. If you look at the blog that Christopher has made, which gives you guys hints for the exercises, then you will notice that he talks a lot about payment streams. Draw the payment streams, draw the payment streams, show me the money. And it is absolutely crucial that we use this concept to understand whichever kind of financial product we are looking at. So let's take a look at payment streams. This also has to do still with the question, what do we mean by present value? So what I noticed, what I mentioned before was present value. Well, what do we mean by that? It depends on when the present is, when we look at something, what our time t is. So down here I have drawn what we call a timeline. So this is t going up along this line, and let us just consider a rather simple annuity in arrear, which is, I have to draw this properly. Let's try to take a look. 1, 2, 3, 4, 5, 6, and so on and so on. So this is an annuity in arrear. Also what we call in Danish, efterbetalt, annuitet, which just means the payments fall in the end of the year, the end of the period. So annuity in arrear. And these are all payments of 1 unit. So 1, 1, 1, 1, 1, 1. And whether it's 100 or 1,000, that's up to you. So if we're asked to calculate the present value of something, the first thing we kind of ask is, well, the present value 1. And maybe it's the initial present value that we think about. So maybe we're looking at everything from here. And for those of you who don't know what the hell I'm drawing, this is an eye. So if we're looking at the initial present value, then what happens is, well, we have to take this 1 unit that is here, and we have to discount it back to time 0. And we take this 1 unit, and we also discount that back to time 0. This 1 unit, and also discount that back to time 0. All the way up to the last unit, which we discount all the way back to time 0. So how does that work? Well, if the interest is constantly I, for example, then the time 0 value of this 1 unit, well, that would be 1 plus I to the minus first, right? And the value of this would be, well, we discount it twice, so it's 1 plus I to the minus second. And we discount this 3 times, so it's 1 plus I to the minus third. So this is the time 0 value of this unit. This is the time 0 value of this unit. I hope you can see my cursor, because or else this doesn't make much sense. And the third line here is the time 0 value of the unit that's paid at time 3. And so on and so on, and we do this all the way until n minus 1. So there's also 1 unit paid at time n minus 1. So this is 1 plus I to the minus n minus 1. And then we have the 1 plus I to the minus n. And if you look in the book, what the book does is it puts all of these into an abstract summation. But here you can just see how much easier payment streams makes it to understand what in the world is going on with these payments. Because then when you have discounted all of the payments back to the place where your I is, then it's just about adding all of these up. So just add, and then you're done. Okay, so that was what happens if we consider the initial present value at time 0. Now, your I might not be at time 0. It might not be what you're interested in. at all. Maybe what you're interested in is to look at this at time n. So let me try to draw the I at time n instead. So what if I'm looking at it here? And what I'm interested in is looking at the present value at time n of the past payments. Well, then what happens? Then I can see, well, there was a payment 1 period ago. So the present value of that now should be 1 plus I to the first. And then 2 periods ago, there was also a payment. So the present value of that should be 1 plus I to the second. And then, well, 3 periods ago, there was also a payment. And accumulated until now, well, it gained interest here, and then here, and then here. So that was 3 times. So that's 1 plus I to the third. Now, if we do that all the way back, then we also have this one. We kind of have to think of it. How many times has this unit gained interest? Well, how much smaller is it than n? Because apparently, if the time value is 1 smaller than n, then it gains interest 1 period. If it's 2 smaller than n, then it gains interest 2 periods. So how much smaller is 3 than n? Well, that's a rather simple question, actually, because it's exactly n minus 3 smaller. And the same goes for the single payment at time 2. So it's 1 plus I n minus 2 and 1 plus I n minus 1. Okay, so now what we can do now is we have the time n value of all of these payments, and then we can just sum them all together again. So this is why payment streams are nice. Now, a tiny detail. What I kind of ignored here is whether this is a contribution or a benefit payment stream. I just kind of said, well, when we're standing here, then it's still a positive payment stream. If we're standing at time 0, it's still a positive payment stream. But when you're doing this exercise, normally, remember, if it is a negative payment stream, then what you want is this. So if, for example, you have some payments at from time 0 to from time 1 to k, for example. So until time k, you have some contribution payments, and this is from an accumulated value point of view. And then from time k to, for example, k plus n, you have benefit payments. Then you can also kind of draw it this way. It's one way to think about it anyways. And then some of these will have minus signs and some of these will have plus signs. Another way to do it is kind of to say, well, I should probably just draw 2 payment streams instead, so that I can say, well, this is the payment stream for C of t, and this is B, and then I can draw the negative lines here. Or some people will prefer to draw them positive here and say, well, I know that it's C of t minus B of t, so B of t, when I draw it for itself, it has the positive lines. There's no one correct way to draw payment streams. It's mostly something that you should think of as a tool to help yourself. So cheers. Happy solving.